In this slide, we're going to discuss the relationships between pressure, volume, and the temperature for a given mass of a gas. And subsequently, we will also look at the effect of mass on the samples. So the very first empirical relation that relates pressure, volume, and temperature and mass is Boyle's law. You may have already learned about Boyle's law in the previous courses and previous years as well. By definition, the law states pressure and the volume are inversely related at constant temperature of the gas and a constant mass. What does this mean to you? Well, this implies if I were to keep the temperature and mass constant, and when I lower the volume by compressing the gas, the pressure should increase. On the other hand, if I keep uh, the pressure, if I keep the temperature and mass constant, but lower the pressure, then I will have to raise the volume. And this simple relationship has been demonstrated in the laboratory. And we can rewrite this statement in a mathematical form as PV equals to constant. That's because pressure is proportional to 1 over volume, inversely related. And therefore, we can replace that proportionality constant with a constant and write PV equals to a constant, where the P is the pressure, V is the volume at a temperature T and for a given mass of the gas. Experimentally, if I were to plot pressure on the y-axis, volume on the x-axis at a constant temperature and mass for a given gas, I will get the red curve. So what does this curve describe to us? Well, it says if I were to move towards the right on the volume axis, means that as the volume is increasing, then the curve predicts that the pressure should drop smoothly. And as you can see here, on the other hand, if were to move on the volume axis towards the left, where I'm reducing the volume of the gas, the pressure of the sample should rise. And so this is a very simple, basic relationship for a given gas sample. Notice that Boyle's law applies to all gases in a rough way, meaning that approximately this is the case for all gases, independent of chemical composition of the gas. And we call these real gases. Now, if I were to make these measurements very precisely, then I would see variations in this. Now, on the right side of the slide, you see an animation from Wikipedia. What is this showing? It shows that there is a gas sample in a cylinder with a piston, and this is immersed in a blue bath. And the bath temperature is kept constant with the flame underneath. And there is a temperature gauge that determines the temperature of the sample. And there is a pressure gauge that measures the pressure of the sample. And we can add or subtract mass by injecting extra gas sample or releasing some gas back in. So we have a means to monitor all different things in a gas sample. For this experiment, we keep the mass constant and we keep the temperature constant. And now, as we compress the gas, that means when you push down the piston, the volume is going to decrease. Now, consequently, notice what happens to the numbers or to the position of the needle on the pressure gauge. Your observations should be then used to plot the volume versus pressure plot on this right side of this graph. Now we can view this animation at the following website. And after watching this animation on the website, complete the graph V versus P on which is on the right side of the animation. Right. So this completes this picture, this slide description.